Hey guys, you're watching Python tutorials on my YouTube channel Python for Microscopists. In this short video, I'm going to talk about evaluating your deep learning model, basically keeping track of your validation loss and accuracy and then plotting it as a function of epochs. So let me jump out of this screen and go back to our Spider IDE. And again, just so you know, I'm using Python 3.5.5. And again, this is because this is the only version I can use. So I, in order to leverage the GPU that I have here, okay, the NVIDIA GPU. And the TensorFlow version I'm using is 1.4 and 2.0.8 Keras, okay? All of these only to make sure that my GPU actually works. If you have a later GPU, or if you don't have a GPU, and if you're working on TensorFlow 2.0 and other versions, most of the stuff I'm talking about should still be very much applicable. Okay, so here is the code from our last few tutorials where I talked about classification of malarial cells using convolutional neural networks. So very simple. Again, I have a folder of cell images called, and subfolders parasitized with 500 images of parasitized cells and uninfected. And similarly, I have a validation folder, so I'm using those to augment my data set. Again, please watch my previous tutorials on this topic so you can be up to speed with this. In the last tutorial, I talked about callbacks. Again, we created the checkpoint, so our model gets saved every so often. And early stopping, so we can stop this when certain conditions are met. And then again, we use log CSV to log the CSV, all the parameters into a CSV file. So here you can quickly see our epoch number, training accuracy loss, validation accuracy, and validation loss. Okay, you can right away take this and then convert this into a pandas data frame and then start plotting. So that's, then you're done, right? So that's one way. The other way is, you see how we are doing model.fit generator. It works great and everything will be saved into our h5 file, but it's customary to actually give this a name. And typically, I don't know why, they give a name called history because it's storing all the historical information as the number of epochs progress. So let's do that. And let's actually run this for 50 epochs so we have enough data points to talk about. And then let's continue the discussion. So let me go ahead and start this. I'm going to pause this video because I don't want you to obviously stare at the screen, even though I have a GPU and this training is a bit faster than usual. So let me go ahead and pause this and continue this in a, once this is done. Well, this thing actually stopped only after 5 epochs, apparently because the early stopping has been achieved. So I think this is good enough. Let's go ahead and first of all, let's see what's in history, right? So the history is stored, and if you actually type history here, you see that it's actually an object. Okay, if you actually look at history.history, you can see that it contains some information. You see accuracy, loss, and validation, accuracy, validation, loss. In fact, let's actually give it a name. A equals to history.history. So what do we see? Let's go to Variable Explorer. It's a dictionary of size 4. Okay, what are these 4 entries in this dictionary? Let's go ahead and expand this. Let's keep this right here. The 4 entries are accuracy, loss, which is the training accuracy, training loss, validation accuracy, and validation loss. And the size is 5 because we only have 5 epochs. In fact, if I open up my accuracy, now you can see these are the 5 values here. So let's actually look at validation loss here. Okay, so here is validation loss. Okay, now as you can see, the loss actually went down at this point, and then it seems to be going up. Now, in fact, I should have actually made my patients to be like 25 or 30 or something, because now things are still changing quite a bit, right? Again, the patience is how many epochs after the minimum of validation accuracy has been found that you want to further go ahead. Okay, so I think this is not fun, so let's actually make my patients to be 30 and let me continue this to be 50 epochs so we can have a quick look at it. Again, I'll pause the video. Okay, so I had to remove our early stopping so I could get this thing go through all the 50 epochs. And now if I look at my dictionary of history.history, you can see that, okay, I have these 4 values: accuracy, loss, validation, accuracy, and validation loss. And each of these is of size 50 because we have 50 epochs. So we have all the data now. So first of all, how do we evaluate? As you can see in this case, I'm actually saving my model to a HDF5 file. And which means now I can actually go ahead and evaluate my model. Again, I'm in the next tutorial, let's talk about loading an existing model. But because we have our final state of the model, we can now do model.evaluate. Okay, I'm doing evaluate generator because, again, my input is coming from a generator, train generator. Again, please watch my tutorial on data augmentation to understand this part. Okay. If you do not have generator or augmented data, then this would be just model.evaluate and then your X and Y values, okay, and then your batch size. That's it. But model.evaluate is what you need. So I'm extracting my loss and accuracy. Again, when you run model.evaluate or evaluate generator, it's going to be reporting 2 values. The first one, loss, and the second one, accuracy. Because I'm inputting or providing train generator or training data as my input, I'm calling them training loss and training accuracy. Similarly, validation loss and or test loss, let's say, instead of, we are using test loss and test accuracy, okay, for my validation data. I'm just going to print these. So let's have a quick look at this, and this should be just a single values, right, for each of this. So it's saying that my training accuracy is 94.9% and my test accuracy is 87.1%, which is okay. I mean, I still can go on for a while and then see if my test accuracy gets better, but this gives a good snapshot of how it's performing on your training data set and on your validation data set. Okay. Now, if you would like to have a look at all of these values, and plot them, you can actually add a callback for TensorBoard, and you can open it in TensorBoard. But that's a different topic altogether. So let's keep things a bit simple. First of all, you can open this CSV file, and then go ahead and plot it. Or because we already have everything stored as part of our history, right? I mean, we looked at this history.history. Let's go ahead and plot it. All I'm trying to do is, first of all, let's go ahead and print the values in the history, right? So these are all the values that got stored. And this corresponds to your validation accuracy and so on. And let's go ahead and plot it. Excuse me. From matplotlib import pyplot as plt, so we can go ahead and plot these values. So, and now I'm just going to plot loss and validation loss, or training loss and validation loss. That's it. Okay, and just using our regular pyplot. So there you go. And my test or validation is still jumping up and down. This is so unstable. Yeah, this is jumping up and down. Maybe more epochs here, or maybe more, of this validation data set. Okay, so here is how you can actually evaluate the performance. And again, I'm not elaborating on why these things are happening. Again, there are many reasons why these things are happening, so there's no point in focusing on this specific example. But I suspect even if I increase my number of epochs, it's still going to do pretty much the same thing in here, right here. So it doesn't seem to be converging very well. So maybe I need to tune some of these other parameters, okay, up here. So I hope you found this tutorial to be useful. And again, please go ahead and work on your own data set and see if you could, by tuning any of these parameters, whether it is batch size. Batch size also has an effect, by the way, on how you do it, right? I mean, if the batch size is too large, there is one effect. If the batch size is too small, then you're not, then you're not kind of generalizing it enough. So again, there are a lot of parameters that you need to tune to get things right. But I'll let you work on your own data set so you can get your own experiences on this. So thank you very much. And again, please do not forget to subscribe to my channel.